Okay, welcome everyone. We're on to the Thursday section of the Term 3 homework sheet for week 6. And we're up to question 40, and we have to look at the picture of this scale drawing of a house plan. It says the scale is 1 to 100, and that's important to keep in mind because that means that everything in real life is 100 times bigger than everything on the little map here on the scale diagram. Question 40 says, what was the size of the main door in the living room? And the hint says we've got to measure the size on the diagram and multiply by the scale factor, which is going to be times 100. So I need you to grab your homework sheet and get a ruler and measure the main door's size on the living room. So if you've measured that now, I've got about 8 millimeters. Okay, you might like to think of it also as maybe 0.8 of a centimetre. That might be easy to go with. We're going to multiply that by 100. When you multiply a decimal by 100, you've got 2 zeros there, so you multiply by going 2 spaces to the right. And if you can imagine a 0 added under that space, it's going to be 80 centimetres. Up to question 41, where it says, what is the area of the study? And when you look at the study is going to have a length, and it's also going to have a breadth. So I need you to pause and measure them in centimetres, and then when you've done that, also multiply them by 100 to get a dimensions for the length and a dimensions down here for the breadth of that. So do that now. Hopefully you've measured that, and the study has a length of about 2 centimetres, so if we multiply by 100 that means 200 centimetres. Now we're probably going to use 2 metres for that because it's more realistic to use metres when talking about the areas of houses. And if you measured the breadth, I've got there as 1.5 centimetres, so that'd be 150 centimetres when you multiply by 100, but we're going to talk about 1.5 metres. Now I want to concentrate on the length and the breadth, because when you're working out the area of a rectangular shape like the study, you go length times breadth. So in this case we're going to go 2 metres times 1.5 metres, and if you calculate that it should be 3 square metres, written as 3 metres squared. The next question says, what is the total area of both bedrooms? So we're going to use the same process as above and work out the area of each bedroom, and then we're going to plus them together. So I want you to go and try and do that now. Hopefully you've measured that and worked it out. The main bedroom, followed by the tick up there, that had just a measurement of approximately 2.5 centimetres by 2.5 centimetres, but in terms of the scale, we're going to multiply them by 100, and it's actually going to end up being 2.5 metres, 2.5 metres by 2.5 metres. If you calculate that, that would be 6.25 square metres. And the second bedroom that we're going to add it to is the bedroom that I've put a tick on, and that had a length of 2 centimetres, so we turn that into 2 metres when we convert it, by a width of 1.5 centimetres, so that turns into 1.5 metres when you convert it using the scale. And so that's going to be 3 square metres just for that bedroom. Now if I add up these two bits together, I'm going to get a total of 9.25 metres squared. Sorry, that one's a little bit messy, but you can see the answer in blue right there. Then it says comment on the size of this house in question 43. Now because this is a fairly open-ended question, comment just means give us a fact or a bit of information about this house. Now I've measured that it's about 7.5 metres long, and it is about 4.5 metres wide. You could work out the area of that if you want to and tell me how many square metres it is, and tell us a little bit about the size of the house, and that would be a good idea for the comment. Anyway, that's good enough for that one, so let's go on to the next section. Okay, we're up to the next section, which is on angles, and the first question says it says for all of them, find the size of the unknown angles in this shape. So here we go. The first question, I want you to think about how many sides we've got. So 1, 2, 3, 4, 5 sides. So that makes us a pentagon, and we learnt in class that a pentagon has an angle sum of 540 degrees. Now if it's a pentagon such that it's regular, which I'm guessing this one is, although it's not really clear, but I'm pretty sure that's a regular one, and I'm sure if we did that again we'd include those little dashes. That means there has to be 5 equal angles inside the pentagon, so 1, 2, 3, 4, 5. Now if you go 540 divided by 5, the missing angle which we call theta, is 540 divided by 5, or 108 degrees, and that's the answer for that one. On to question 45. Now you might remember that a full revolution, when you go around a circle, has to add up to 360 degrees. So if we take away the 90-degree right angle, which is signified by that little box there, that leaves us with 270 degrees left for these two x angles. So what we know is that the two x angles have to make up 270 degrees. This is a bit like a simple equation where we're going to divide by 2, and the x is therefore going to be 135 degrees each. That's the answer for that one. Now we're up to question 46. I want you to notice that there's two angles A and B that we have to figure out. So let's start with the A. When you look at the A, you realise that the A and the 52 degrees angles, they make up a bit of a straight line, and they've got a special name called supplementary angles. And what's special about supplementary angles is that when you add them together, they have to equal 180 degrees. So if we use our equation techniques and say, well, let's get rid of that 52 by subtracting and cancelling, we get an answer of the A equaling 180 minus 52, which is 128 degrees. Now when you look at B, you might notice that it makes a bit of a crisscross with the 52, and they've got a special name called vertically opposite angles. And what's special about vertically opposite angles is that they are exactly equal. So the B has to be 52 degrees, and there are the answers for question 46. Now we're up to question 47, where we have to work out three angles, A, B, and C. Now let's focus on the A first. I want you to notice that the A makes a bit of a Z shape with the 74. So let's have a look at that Z shape there. Now what's special about that is that Z-shaped angles are called alternate angles, and they happen to be equal. So when I'm doing the A, I'm focusing on that little Z shape. And if the Z-shaped or alternate angles have to be equal, then the A has to be 72 degrees. Now I want you to focus on the B. Now the B and the 74 that we just figured out make a bit of a C shape. Now what I want you to realise is that when you have a C shape, they are called co-interior angles, and the special thing about them is they have to add up to 180 degrees. So that B plus the 74 makes 180 degrees. So that means that the B has to be 106 degrees. Now finally the C. I want you to notice that the C is vertically opposite with the B, or you could say it makes up a 180 degree with the A. I'm going to pick the first one I said. So I know that the B and the C are vertically opposite. So C has to be the same as B, which is 106 degrees. Okay, now we're up to the final section, which is question 48. Now we're going to notice this is a triangle. In fact, it's called a scalene triangle. But one thing that's special about triangles is that all of the angles, when you add them together, they have to add up to 180 degrees. So what I'd like you to figure out is, what does the A have to be to make up 180 degrees with these angles of 17 and 127? Now you might go away and think about that, and hopefully you have, and you should be going 180 minus 17 minus 127, and that should reveal our answer, which is 36 degrees. So that's correct for that one. Up to number 49, which is the final one for now. One of the things we learn about is something called the external angle of a triangle theorem. And that's where it says that the external angle, which is 130, has to equal the sum of the two opposite interior angles. So we know that the A and the 50 together, they have to equal 130 degrees in total. Now using your simple equation techniques, or just a bit of common sense by observation, you'd realise that the A has to be 130 minus 50, or 80 degrees. Right, that's the end of this day's sheet. Hopefully you went okay with it, and once again, if you find any errors, let me know about it, please. Goodbye.